When one function is composed within another function, you have a composition of functions. Let's go over to the classroom to review how to compose functions. Okay, let's talk about composition of functions. First of all, I have to give you two functions. F of x, I'm going to call the function f of x equals 3x plus 2. And g of x equals x squared plus 5. Now, for composition of functions, it's going to look like one function stuck inside another, and that's why it's pronounced. Now, let me write the notation. It looks like f of g of x. It looks like g of x is stuck inside f, and that's basically what you're going to do when you do to calculate this composition. F composite g of x is how it's most commonly pronounced. So you'll notice that g of x is inside. It's composed within f. So that means, what does that mean to you in English? That means you're going to start with this g of x function. And you're going to come over here and you're going to find x in f of x. And you're just going to sub it into it. So now it looks like this. 3 times the quantity x squared plus 5 plus 2. That's composite function. It's composed within f. So you just got to distribute the 3, so you're going to get 3x squared plus 15. And bring the plus 2 down, just combine those two guys. So f composite g of x is going to be equal to 3x squared plus 17. Now let's do it the other way around. Let's do g composite f of x. That means you're going to start with 3x plus 2, and you're going to go look for x in g of x, and you're going to plug it in its place. So you're going to sub it in right here. Now, if you had more than one x, you would have to put it more in one place. But you only have one x there. So it's going to look like this. The quantity 3x plus 2 squared plus 5. Now, please don't make this mistake, and I think I covered this when we were talking about exponents, rules of exponents. Since this is a plus in here, this is a quantity. You cannot take this power 2 and distribute to each term. So what's probably easiest for you to do is just to write it out twice. 3x plus 2 times 3x plus 2. Don't forget your plus 5. Now take this binomial times this binomial. Use the FOIL method, so that's what we're going to do next. So we're going to get 3x times 3x, that's 9x squared. 3x times 2, that's going to be 6x. Now take the 2 times 3x, another 6x. 2 times 2 is 4. Bring the plus 5 down. Combine like terms and you'll be done. G composite f of x will be equal to 9x squared plus 12x plus 9. What you're going to notice is a lot of times it looks like f composite g of x and g composite f of x. Some people get confused. They think it's multiplication. It's not. It's a composition. If you notice, if you look at the two answers, are these guys equal? No. So this isn't multiplication. Now let's take a look at a real special situation. Say I gave you f of x was equal, and you know what, since it's special, let's put a little star by it, x cubed. And g of x, I'm going to write as the cube root of x. Or, if you want, don't forget we can write it as x to the 1/3. Now, if you were to do their composition, let's do f composite g of x first. That means we're going to start with g of x. That's the inside part. You're going to take that x to the 1/3. You're going to plug it in. Wherever you see an x, you're going to plug it in here. So it's going to look like this. X to the 1/3 cubed. Which, if you remember your rules of exponents, you're going to take this 3 times the 1/3. It's going to give you x to the 3/3, which is x to the first, or x. Let's do g composite f of x. We're going to take x cubed and stick it in here into the x to the 1/3. So it's going to look like this, x cubed raised to the 1/3. Oh, that's going to give you x to the 3 over 3, which is equal to x. Oh, so there are situations in which f composite g is equal to g composite f. So this is a true statement. It depends on what you're given. F composite g is equal to g composite f of x. But what did you notice? That they were both answer of x. By definition, that means f of x and g of x are inverses of each other.